A rectangle has an area of 24. List all possible length and width pairs. Remember that area can be found by taking the length times the width. And don't let your eyes deceive you, because they want all possible length and width pairs. So this rectangle may not look exactly like this. It could have a really long length and a short width, or a long width and a short length. Or it could look longer than it does now. We want to list all possible length and width pairs. I like to begin with the number 1. I know 1 goes into everything, so it's always going to be involved in a possible length width pair. 1 can definitely be my length or my width. And let's say that if 1 is my width, then what is my length? 1 times something is 24. Remember, the area of a rectangle is length times width. Well, I know that 1 times 24 gives me 24. So 1 length width pair would be 1 and 24. That could be the length is 1 and the width is 24, or the width is 24 and the length is 1. The next number after 1 is 2. Does 2 go into 24? Well, 24 is an even number, and you can tell that by seeing, okay, the number that 24 ends with is a 4, and 4 is an even number, therefore 2 will go into 24 evenly. So let's say that 2 were my width. 2 times something does give me 24. Then my length would be 12, because 2 times 12 is 24. Now I'm going to try 3. There's actually a pretty cool trick to see if 3 goes into a number. The number that I'm looking at is 24. If the sum of the digits is the number that 3 goes into, then 3 goes into that number. What? Okay, so 24 is made up of 2 digits, a 2 and a 4. So I'm going to take 2 and add 4. That number is 6. If 3 goes into 6, then 3 goes into 24. What? Isn't that crazy? That means that I know automatically that 3 goes into 42, because 4 plus 2 is the same as 2 plus 4. It gives me 6. So 3 does go into 24. If 3 were the width of this rectangle, the length would be 3 times what is 24? That would be 8. What about 4? Does 4 go into this? 4 can only go into even numbers, so it has to be even. But even if it's even, doesn't mean 4 goes into it. So we're going to have to see, does 4 go into 24? And if you remember your times tables, then you may remember that 4 times 6 gives you 24. So if the width of this rectangle is 4, then the length would be 6, or vice versa. What about 5? Well, 5 only goes into numbers that end in 5 or in 0. This one ends in a 4, so 5 does not go into 24. All right, so we've come up with a list of numbers that go into 24 and there's no fractions. What are these numbers called? They actually have a specific name. These are called factors of 24. Factors would be numbers that divide evenly, meaning there are no fractions or decimals or remainders left over. The square has an area of 16. What are its side lengths? Well, what do we know about a square? We can actually describe a square as a type of rectangle with equal length and width, giving a square all 4 equal side lengths. So if 16 is the area of a square, what are the length and width? Well, 16 is the area is length times width, and in this case, the length and the width are the same. So when you have the same thing being multiplied by itself, there's actually a word for that. It is squared. So something squared gets me 16. That is 4. Yes, 4 squared, or 4 times 4, gives me 16. So the side lengths of this square are 4. The area of each rectangle is written inside. Find the missing length or width. Area is equal to length times width. In this case, 50 is our area. I do not know what our width is, but I do know our length is 10. So 10 times something should get me 50. I could also treat this like an equation. Divided by 10, divided by 10. So my width is going to be equal to 50 divided by 10. That is 5. Let's check. 5 times 10. Does that equal 50? Yeah, 5 times 10 is 50. So if the length of this rectangle is 10 and the area is 50, then its width is 5. Let's look at this one. The area is 100. Length times width is equal to 100. 10 times what gives me 100? Well, I know that. That is 10. My length is 9, but I don't know my width. The area here is 18. So I want to know what times 9 is 18. That would be 2. 2 times 9 is 18. Something times 5 is 25. 36 times something is 72. 8 times something is 16. See if you can solve for these missing pieces. You should have 5 times 5 is 25. 36 times 2 is 72. 8 times 2 is 16. Which of the rectangles above are also squares? So, which of these rectangles have equal side length? Let's take a look at them. The rectangle from part B has a length of 10 and a width of 10. That makes this rectangle a special rectangle called a square. The rectangle in part D, that has equal side length, which makes this a special rectangle called a square. Any others? No. So that would be rectangles in parts B and D. What if we have monomials? Something times 8x is 48x squared. 4x times something is 32x squared. And something times 9x is 36x squared. This area has an x squared in it, which means our product needs to have x times x. I only see an x here. Okay, this is not an x squared, this is just an x. Technically, it's x to the power of 1. So I know my width has to have an x in it. That way, x times x results in x squared. Now let's look at the numbers. What times 8 gives me 48 now that I know the x's are taken care of? 48 divided by 8 is another way you could ask yourself this question. And I would say that is 6. So 6x times 8x is that 48x squared. I like to write the numbers first, so I'm going to write 6 times 8 times x times x. So just rearrange the order because it's a product. 6 times 8 is 48. X times x is x squared. So yes, our width of this rectangle is 6x. What about the length of the rectangle in part B? Because my area has x squared and my width only has an x to the power of 1, my length has to have an x in it. Now let's look at the number. 4 times what gives me 32? That is 8. Check. 4 times 8 times x, that does indeed equal 32 x squared. So the length of this rectangle is 8x. The width of this rectangle, the area has an x squared in it, but the length only has an x to the 1. Therefore, the width must have an x to the 1 in it as well. And then what number times 9 gives you 36? That is 4. Is 4x times 9x 36x squared? Yes, it is. 4 times 9 times x does give you 36, and then x times x is, of course, x squared. So something times 9x gives me 81x squared. 12x squared times something gives you 144x to the 4th. Ooh, a little different. And this one is 15x times something is equal to 45x cubed. 81x squared. Now, the area has an x squared, the length has an x, so the width must also have an x. If the length had an x squared, then the width wouldn't need any x's. But there has to be another one so that x times x results in x squared. And what number times 9 is 81? That is 9. 9x times 9x is 81x squared. Our resulting exponent is x to the power of 4. Ooh. And our width has x to the power of 2. I'm going to write that out expanded. So 12 times x times x. And if I were to write this expanded, that would be 144 times x times x times x times x. So the width has x times x, that's 2 of them being multiplied, and the area has x times x times x times x, so 4 of them being multiplied. That means the length must have 2 of them being multiplied, so that x times x times x times x does indeed give me that product of x times itself 4 times. So the length here is something x squared, and 12 times what gives me 144? That indeed is 12. Let's check that. So 12 times 12, and then I have an x times x attached to this 12, and an x times x being multiplied to this 12. So that would be 144, and that is x to the power of 4. So this is correct. The length of this rectangle is 12x squared. And the length of this rectangle, well, the area has x to the power of 3, and the length has x to the power of 1. Okay, you don't have to write the 1 there. So what should the length have? X to the power of... If I were to expand this, that would be 45 times x times x times x. So there are 3 of them multiplied by each other, and the width has x to the 1 in it, so your length has to have an x times x. That way, you result in x times itself 3 times. And x times x can be written as x squared, so the length must involve x squared. And what number would that be? 15 times what gives you 45? That is 3. So 3x squared, is that the length? Let's check it out. All right, the numbers first. So 15 times 3, and then we have times this purple x, and then this is x to the power of 2 in blue, so that would be another x times x. And does that result in 45x cubed? Well, 15 times 3, that indeed is 45, and x cubed. X times x times x. Which of the rectangles above are also squares? So which of these rectangles have an equal length and width? The length and width are the same. 6x, 8x, no. 8x, 4x, no. 4x, 9x, no. 9x, 9x, woohoo! We have a square here in part D, and we also have another square in part E. Those are the same side lengths as well. That would be parts D and E. To recap, for a rectangle, the area is width times length. That means if we take the area of a rectangle and we divide the width, we will get the length. And if we take the area and divide the length, we will get the width. And a square is a special type of rectangle where the length is equal to the width. All the side lengths are the same.